Okay, add another component to the diagram to measure the voltage of component X. All right, well, hopefully you know that the component that we use to measure voltage is a voltmeter. Okay, and that's how we have to draw it, a V in a circle, okay, with wires coming out of either side of it. Now, we've got to measure the voltage across component X, so it's important that we get this in the right place. Voltmeters go in parallel with the component that you're measuring the voltage across, and then they need to connect either side. And to be absolutely perfect, okay, you want to show a little blob on each of those wires to show that it's a connection. Component X, okay, you can see that all of the kind of resistors have got, start off with a kind of rectangular box. So that would be a fixed value resistor if it's just a rectangular box. And then there's different things that we can have. We could have like a variable resistor like that. But this resistor has got two arrows shining into it. Okay, and the two arrows signify light. So this is a resistor which depends on light, or to say it another way, a light-dependent resistor. You can write it out in words, or you can use the abbreviation. Either is fine. So this shows us how the resistance of component X changes with light intensity. Okay, use the graph to determine the resistance of component X when the light intensity is 4 arbitrary units. So we go from 4 arbitrary units up to the graph right there. Okay, and then we've got to go across to the y-axis, and we need to be able to read to the nearest small square. So if that's 1,000 there, then that's going to be 1,500 there, and that's going to be 1,700 there. Okay. Now, you can see because I've drawn on the graph, that's me using the graph. So we're going to get one mark for kind of showing our working, another mark for showing the correct answer there. Explain what happens to the brightness of the lamp when component X is covered with a dark sheet of paper. Some of you guys use the acronym BIRD, TURD, to help you out here. Okay, the BIRD is for LDRs, and it stands for brightness up, resistance down. Okay, and the TURD is for thermistors, which stands for temperature up, resistance down. Okay, so it's the BIRD that we're interested in, isn't it? If you couldn't remember that acronym, you can still work it out by looking at the graph. You can see that, look, if we're going to cover up component X with a dark sheet of paper, then that means that there's going to be less light hitting the LDR. So look, if the light decreases, what happens to the resistance? The resistance increases. Okay, so that's the first way that you could score a mark here, is by saying that the resistance of the LDR increases. Okay, now if you just go back and look at the circuit, okay, if the resistance here increases, then what's that going to do to the current in the circuit? Well, the overall voltage of the circuit stays the same, okay, but if the resistance in the series circuit increases, then that's going to decrease the current. Okay, so then that's the next thing that we can say, okay, that the current decreases in the circuit. And then finally, what's that going to do to the brightness of a lamp? Well, if we decrease the current, that's going to decrease the brightness of the lamp. Great stuff, and that's the end of the question and the end of the standard section of the paper.